Hey everyone, welcome back. As we discussed in the previous video, we will be deploying the application resources on LocalStack locally using Terraform. So Terraform allows you to automate the management of AWS resources such as containers, Lambda functions, and so on by declaring them in HashiCorp configuration language. In this video, we discuss how Terraform and LocalStack can be used together. So let's get started. For deploying using Terraform, we will be using tflocal, a small wrapper script to run Terraform against LocalStack. It's similar to AWS Local that we used for AWS. You can also find the code of it on GitHub, as you can see on my screen. Now let's dive into Terraform code and let's see that how resources are being made. So in the last video, we created two DynamoDB tables manually, the pet store pets and food store food. Now let's try to create that with Terraform. Now let's start the local stack. So local stack is up and running. So I will be using tflocal here as I already discussed. You can install it by pip install terraform local. It's already installed in my environment, so I'm not going to install it. So I'm going to create a folder terraform. As you can see that it has main.tf file. So I'm going to declare a resource block for creating AWS DynamoDB table. And the name would be DynamoDB table food store foods. Next, I'm going to set the name of DynamoDB table to food store foods. Then I will define the billing mode to pay per request. And next I will define the hash key as food ID. So this hash key is used to uniquely identify items in the table. And lastly, I will define attribute with the name as food ID. And type as string. So this defines an attribute for the DynamoDB table. In this case, an attribute named food ID is specified with the type of S, which is string. This aligns with the earlier declaration of food ID as the hash key. So overall, this code is basically creating a DynamoDB table named food store foods with a billing mode of pay per request and a hash key attribute food ID of type string. So now let's initialize the Terraform using the following command, tflocal init. So this basically initializes the backend and the Terraform has been successfully initialized. Now let's do tflocal plan, which creates an execution plan and lets you preview the changes. So as you can see, it has created AWS DynamoDB table with all these configuration. And finally, I'm going to do tflocal apply. So this will basically provision the DynamoDB specified in the configuration. Cool, it has been completed. Now let's explore our web app. So let's explore resource browser to see if DynamoDB has been created. And I can see that food store foods table has been created with the attribute type as S, the attribute name as food ID and hash as food ID. Now we have seen that how we can use Terraform to create resources in LocalStack. Let's move to our demo application. For our demo application, we already have main.tf, as you can see on my screen, that contains all the providers, variables, and resources to be created. This Terraform script defines an infrastructure setup on AWS for a microservice architecture. Let's break it down into different sections. You can also find this Terraform file on GitHub. So here we have provider and variables defined that are required for these resources. Then further, we create DynamoDB table where we are storing data for food store and pet store. We also define the networking resources such as VPC, subnet, and then further. Now, once this Terraform script completes, it gives output as information about the deployed resources such as API URLs, ECS cluster name, VPC ID, etc. Now, let's run the TF script and see the output. So LocalStack is already up and running, as you can see on my screen. So now let's create the AWS infrastructure for this demo application locally. So we will go inside the Terraform directory. Then we will initialize Terraform by tflocal init. Now we will apply Terraform configuration. This will create the resources. So we will wait for the resources to be created. So congratulations, we have deployed all the resources. Now you can see the output with API URLs, ECS cluster name, VPC ID, and etc. Now let's check this on LocalStack web app. So we will go to app.localstack.cloud. So now let's check Stack Insights. Stack Insights enable LocalStack users to report AWS API usage telemetry of LocalStack runs to their LocalStack account. It provides usage analytics and insights into the testing process overall. As you can see on my screen, you can see the different service API calls that have been made to LocalStack. Now let's go to Resource Browser and check the current status. So there are different services which are running. Now let's check the DynamoDB table that we created using Terraform. So as you can see, we have food store and pet store, which are already there. Congratulations! We were able to learn how to create AWS resources on LocalStack using tflocal. We were also able to deploy all the AWS resources for the demo application. In the next video, let's do the same using AWS CloudFormation, another LocalStack integration.